Okay, so this was meant to be part of yesterday's AI track, but unfortunately I couldn't get there on time, so we'll do it now. But basically the talk is about AI in security, particularly in Web3 security, and how we use it in our company. Because we are Oak Security, we are a blockchain security firm. We've been around in one form or another since 2017. Currently 52 security researchers. We've audited over 600 projects. And well, here there are some icons of some logos of our clients. You will recognize a lot of Cosmos ecosystem there. Myself, I'm one of the founders. I am a computer scientist. I've got a background in distributed systems and cybersecurity. I've got 20 plus years, well, more than 20 years of industry experience. And I first dabbled with artificial intelligence in '97. The reason I put this up here is because I want to emphasize that AI is not new, right? What is new now is that non-expert users can interact with LLMs, large language modules, which make AI much more accessible, which causes some issues and has some advantages, of course. So before I want to get into how we use AI as a company for auditing smart contracts and blockchains, I want to quickly talk about vibe coding, using AI to produce code. And because it's got a similar problem, which we get to. So this is a statement a well-known developer made to me. I've sort of left him anonymous here. But basically he said he's 10 times more effective since he's using AI tooling in his programming. So that would mean his 40-hour week is now a 4-hour week, which is probably exaggerated. But basically he's bored, right? He's asking us for work, you know, if he can audit for us, because he's got so much spare time in his day job. So that's an example of how AI can be really useful in the hands of a domain expert, right? Someone that knows how coding works. On the flip side, as auditors, we get a lot of code bases now, and it's getting worse in the last few months, where we see over-complex code bases, blocks of code that don't do anything in a code base. When you talk to the developer team about it, they don't understand what they've written because they haven't written it. They've got an AI to write it. Invariant checks are missing. There are uncovered edge cases. And you know, when we tell them to go back and improve the test coverage, they produce at 100% test coverage. But when we look at the tests, they don't test for anything useful, right? So they're testing the wrong thing. And that's an example of we as auditors have to find 10 times the efficiency to make sense of the mess AI has created in the wrong hands, right? So these are not domain experts. These are unexperienced developers that use AI the wrong way. And I'm mentioning this as an example because for security purposes, that's very similar, right? You need domain knowledge to use AI effectively. There's this idea of these autonomous AI agents magically protecting the blockchain. And the news seems to support this, right? There are some headlines here of Google AI stopping some exploits, and a zero-day exploit being spotted in the Linux kernel source code. And these are all good examples, but they don't tell the whole story, right? This here is a research paper I've read. And there are many of these around now, and they all have slightly different numbers, but they all sort of back up what we see in our day-to-day work. So large language models with GPT-4 model in this case, they found were 96% effective in terms of precision. So basically it means if an AI detects the vulnerability, it's usually right. But they also found that 40% of the vulnerabilities are still missed, right? And when it comes to fuzzers, type of testing, fuzz testing it's called. Don't want to get into details, but that's something that can be automated quite easily with AI, they found, right? In the sense that 90% precision and a much lower noise ratio. So here is a case where AI is actually helping the human security researcher a lot to make their work easier. And all these numbers, they might be different in the latest research paper, and it changes daily. I've just read that OpenAI have released a new agent that is supposed to be very good. I haven't had a chance to check it out yet. But basically, the emphasis is there that AI is very good to automate certain things, but it needs human domain expertise. There's a case study here, and this is from our audit report, which we wrote 2024 of Cosmos SDK. When in the long version of this talk, I go through it in more detail. Here, I'll just mention it very quickly in the interest of time. But basically, the first critical issue we found was something relatively standard. It's a pattern of unbounded execution problems where you basically do your own denial of service, or that can happen, that you run into a resource problem. That's very easy to detect with tools, and we detect this type of thing with tools. The second critical issue we found in that audit required deep understanding of the business logic, right? It was basically something to do with how different accounts can be set up to do certain things, to interact across a very complex business logic, and that we've not managed to replicate this finding with AI, right? So it sort of backs up what this paper has said. Some issues are missed, the more complex one that require understanding of the business logic. This pen tester here is another example. This is not our pen tester, but it's a pen tester that have become famous for being #1 on the HackerOne's leaderboard. And it does find a lot of issues, including critical issues, but it still needs a human to validate all the findings. And it tends to find standardized things. Even that standardized, easy sort of pattern thing might be 0 day. It's still something that is relatively easy to spot, or would be relatively easy to spot for a human with a checklist as well. So the takeaway is that all these tools are very good at making the work of the auditor more efficient, but they have to be reused correctly, and that's what we are trying to do in our daily operations. So what we do, and we call that the co-pilot model, which sort of explains itself, we use AI to do the surface scanning, looking for known vulnerabilities, to get the easy finds out of the way, right? We use it for code comprehension, at least initially, right? Obviously, we don't rely on an AI to tell us how our protocol works, but it is very easy to dive into business logic using an AI to get the first high-level understanding and then dive deeper. We use it to validate attack vectors we've already found. We use it to set up fuzzing and generate exploits based on this, proof of concepts that we show our clients. And we use it a lot for documenting and reporting, right? That's where large language modules are very good. It's in the name, language, right? They can help us write up complex issues in a form that is easy, that is standardized and easy to understand by our clients. And then the human, our auditors, they are freed up to handle other things. Like they have to tell the AI the context of this code base, right? They have to understand the context themselves, obviously, but they also have to use it to make the LLM work correctly. They have to understand the business logic, they have to think about the economics, and they have to think about game theory vulnerabilities, which is where we have found the AI is still not good enough to replace our auditors. Not that we want to replace them, but we want to make them as efficient as possible, of course. So the way of working really means we can use AI, large language model, effectively to reduce audit fatigue. No auditor likes going through checklists, and no auditor likes writing reports, right? So that's already a lot of stress out of the way. We can increase coverage because we have more time, or we can compress the timeline, right? It's a mix of the two things. So how can a security auditor work with an LLM, right? Because the sort of naive way of thinking is to just copy a piece of code into ChatGPT and say, find all the issues, right? That doesn't work. So before we can interact with an LLM, our auditors tend to enhance and format the data, right? Ideally, they would reduce the code base to a best case scenario with one happy path and no recursions, because that's the way LLMs work best, right? They work based on tokens, Again, can't go into all the details in the time remaining, but basically, the more linear the code base, the easier it is for an LLM to make sense of it. The realistic case, however, is that we can remove the boilerplate. I mean, we can't rewrite the code for the client so that it's easier to pass by an LLM, of course. But what we can do is remove boilerplate code. We can reduce modules that are not important for security. Right? We can tell LLMI which modules they are, or we can remove them by hand. And we have to tell them the context, right? The LLM needs to know how the protocol is intended to be used and what the intended architecture is and the specification. And we have to do that without being too verbose, because at some point, the prompt gets too large for an LLM to manage correctly. And you also have to avoid multi-shot prompts, because, you know, it's like, the code does this, now it does this, now you have to add this, to give it several prompts, one after the other, and answering to the LLM's prompt usually gets worse with every iteration, right? That's what's called empty context. Basically, you tell the LLM as much as you know in one go in a very concise way. And that's not easy to do, right? You need a lot of domain experience to do that with a piece of code. And importantly, you need to understand it. And then we use specialized agents, which interact with the system prompts, and they can use POCs. Now, we use different auditors that all work slightly differently, but that's basically how most of them work. When it gets too complicated, we find the LLM starts getting useless, right? If we find ourselves in fine-tuning it too much and getting lost in hyperparameterization, what it's called, then we just stop and do it manually. Last thing I want to mention here, how we work with LLMs, is data protection, right? One thing that is very important, that the audits are usually in the context of protected source code. We sign NDAs with our customers. We can't just upload things to a cloud LLM, which means we need very powerful hardware, and our auditors need to run LLMs locally, which also limits the thing further. Okay, so that's just a quick summary how we use AI, but as much as AI we use and as much we make our audits better and more efficient with or without MI, there's another big problem, and that's most Web3 projects these days get exploited through other means, right? They either share their codes accidentally, or they get their keys stolen, or they hire a North Korean hacker in their development team. That has happened. Or they fall for phishing and social engineering attacks, right? And the case in point is this checklist, this leaderboard from the Rect News website, which lists the top 10 projects, or the top 10 exploits in terms of funds stolen. And this is up to date, right? I updated this 2 days ago. And I go through it quickly because I don't have time, to go through it in detail. But basically, 6 out of the top 10 projects have nothing to do with code security, right? All these exploits are due to poor operational security and poor use of cryptography, or some erroneous human intervention, right? And I'm putting this up just because I want to remind everyone that they should talk to us or other security companies, we are not the only ones that offer this, as early as possible, right? Don't wait until you have code to audit. Design, development, release, operation, in all these phases, we and others can provide services. If we can't provide a service, we find a partner that can talk to us as soon as possible. And I don't have more time. Wish I could go into the details of all these AI use cases and talk about more examples. But that's it for now. You can find us here. If you scan this code, I think it gets you to one of these, probably the X or Twitter account. And you can also schedule a call with me directly. Thank you.
Wonderful, wonderful.